Hi. Hey, hey, hey. Hi. Is it a bit loud? I think it should go down a bit. I should be live. Is it a bit loud? I think it should go down a bit. I should be live. Is it a bit loud? I think it should go down a bit. What is that beeping? Is there a high-pitched beeping? What is that beeping? Is there a high-pitched beeping? Oh, I need to stop recording desktop audio because there's a because there's an echo. But is there a high-pitched beeping? But there doesn't seem to be a high-pitched beep. Hi. Okay. All is in order, and I better mute myself because it's a bit strange hearing myself speak. Hi, Callum. Am I going to say hi, Callum? Oh, and I mute myself. Right, I didn't hear myself say hi. Oh, I missed it. I muted myself at the moment when I. Anyway. Da 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 da. Da, 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 da. And everything is ready. Da, 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 da. And OBS and the device and ain't that fancy. So last time we made this thing. It's stupid, but it's this, and you can say hi, and I can change the speed at which it moves with this speed. I get a speed, and a bit slower, and now it's different. And so we're continuing from that, going through the documentation. Let's see. Oh, it's too small. I don't want it that small. Bigger. Well, that's too big. So we have the Sprite 2D node. We got towards the bottom. Sprite 2D. It inherits the properties. We've printed hello world. Aha, we got to here. Games work by rendering many images per second on a frame. It's a process which happens every frame the game updates. Wait, am I still open in a window? No. And I should be live, right? Am I live? Well, of course I'm live. I just tested that. What am I talking? So if you define process, it runs every frame. It's a tick. It goes tick, 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 tick. Usually 60 frames per second. See? No, 30. 30. Consoles. 60. Or 240 if you're crazy. You measure the frames per second. I know! And you multiply by delta. Now delta just means the change in time since the last frame. So you get a you get a frame that goes as quick as it can. Like I can only do it this quick, but a computer might go like this quick, or it might it'd go even quicker. The point is it goes as fast as it's able to, unless it's capped. But it goes as quickly as it's able to, which means if you have something like rotate by 10 on process, which is every frame, because every frame might be quicker, or it might the frame might only be this quick. It might be slower because your equipment might not be as good, or the code might be doing a lot of things. So the duration of each frame can always be different. But the delta is the time between each thing. So if I do it like this, that's about 2 a second, which would be a delta time of 0.5, because between the first frame and the next frame and the next one, there's a delay of 0.5 seconds. So if you have 10 and you multiply it by delta, which is how far through a second we are, or how much of a second this took, we times it by the time, which gives us a consistent value per seconds, no matter how quickly your thing is running. So this will add 10 every single frame, and now this will add 10 every second. That's the point of delta. And we had it set to pi before, because that's what the script told us to do. So, the funky keyword defines a new function. Yes, we know. You can control-click to open up the document. Oh, that's cool. So control-click and we get pi. Huh, pi goes up to this. I thought it was bigger than that. That's good. They figured out the end of pi. I thought they should have figured that out ages ago. Numeric infinity is only a concept with floating point numbers and has no equivalent for integers. Tau Ceti. Oh. Was it Tau Ceti 5 or Tau Ceti 9? Not a number. Nana. Close. And I can check out process. And it's see, delta. Called on each idle frame after the physics ticks. Delta is the time between frames in seconds. It's only called if processing is enabled for this node. This is very nice to have all this information just written out. Happens in the order of process priority. Lower values are called first. So if you need something to be processed before something else, you can screw with the process priority. Frame delta may be post-processed by delta smoothing. Well, what does that do? Delta smoothing, if true, an engine filters the time and attempts to compensate for random variations. So it tries to smooth it out. No, I don't want. I just want to close it. Can I close it without having to control? Oh, it's those things. Can I control T for a new script? No, I can't. So the line inside the function increments our sprite's rotation every frame. Rotation is inherited, so it has that as access. So moving forward, now let's make the node move. And we're going to just add the position with the velocity, which I call the velocity the speed because I'm a scrub. No, it's speed here. So where do they get velocity from? Oh, they made velocity. Oh, it has to be 2. Of course, it has to be 2D. So var velocity, and that's vector 2, because I'm capable and pedantic. so vector 2, and that is a vector 2 up, rotated, rotation, times speed, right? So the rotation must be the value of this. Maybe this is so you can get, so up. So the up gives you, like this is right, and this is up. And I guess what it's doing is it takes the up value and then you add its rotation, so that as it's can I rotate you? How did I do that? So as it's rotated, now if we just use up, that's still this. But if we include rotation, now up is that because it's rotated to there. That's my guess. And then we multiply it by speed. Because the up is a normal, and a normal vector is between 0 and 1, and up will always be 1. So we times it by the speed to make it 400. So that instead of only moving up by 1 unit, which would be very slow, it moves up by 400 units, which is faster. So that's how this works, I'm guessing. And then the position, which must be inherited from sprite 2D, we add it to the velocity times the delta for, you know, the thing that we talked about, where it's going to make it stable. What? Why did you go away? Come back here. Why do you leave me? It's not spinning. Or maybe it is spinning, it's just spinning very slowly. Oh, we're not timesing by delta. Ah. Ah. See, didn't even look at the documentation. I can think. The little rat has a brain, and he has an arm and a tail, and an ear, and another ear, and no, that's the same tail. It's the same tail, and that's all he has. He doesn't have anything else. He has a chicory. Now, so the var keyword defines a new variable, and so we make it as a local variable for velocity. We get the 2D up vector. Well, the cool part is we can also just do this. Up. What was the button to get the documentation? Control click. So the up unit vector. So y is down in 2D. So this points y minus y. Remember? Up. So up points. Yeah, up points down, and you know, computers. But it's a 1 that points up, and then rotated. No, not F12. Can I change it to F12? For some reason, I really want to click F12. Well, it doesn't have a event documentation. Maybe I can F12. And now can I press F12? Oh, I like F12 much more. I don't know why I want to press F12. Maybe I use a piece of software. I mean, Blender doesn't have F12, neither does Unreal. At least I don't. No, I'm not sure what I've used that makes me want to press F12. Maybe it's because if you're in a browser, you can press F12 and see the inspector. I think that might be what it is. See, if I go into the docs and I press F12, I get the inspector. Hopefully that doesn't dox me anything, like my IP address. Does it have my IP address? Body? Well, it just seems to be the website. I think I'm safe. I don't have to type to kill. I don't have to type killbind, you know, myself. I had a list of information for Godot notes. Where did I put them? Knowledge. Stupid. Knowledge. Knowledge. Software. Godot. JNotes. So F12. Documentation. Documentation of a selected element in code editor. So sprite 2D. Well, I don't want sprite 2D. I want rotated. But where was rotated? Well, I didn't open project settings. I rotated. Maybe it's underneath the vector as a centered flip. Get wrecked. Well, it gives us a tooltip. So method vector2 rotate returns the result of rotating this vector by the angle in radians. But it doesn't let me see the thing. Oh, there we go. It returns the result of, yeah, we figured it out. So we now have something that spins in a circle. To run in place. No, it spins in a circle. Pointing and calling the vector 2 rotated. A vector pointing forward relative to our icon, multiplied by our speed, gives a velocity which we then use to move it forwards. It runs in circles. Moving a node like that does not take into account colliding with physics, but we'll deal with that later. Our node currently moves by itself. Next we'll have player inputs that will control it, and the complete script which we have. Alright, Now player inputs. So now we've created the first scripts. We'll give input to the player. The two main ways of doing that is with the built-in callbacks, unhandled inputs. But I doubt what we want is the unhandled input. We want to handle the input, right? Because every frame the player presses a key, it's the tool you want to use. It's the tool you want to use to react to events that don't happen every frame, like pressing space to jump. Alright. And then you have input, singleton, which I don't know what a singleton is. I've heard the name a lot of times, but I don't actually know what it is. What is a singleton? A singleton is someone who doesn't have a romantic partner. No. An object-oriented design pattern that ensures a class has only one instance and provides a global access point to that instance. This pattern is useful for managing shared resources like database connections where only one instance is needed. So it's a what is it called in Python? A class method? What's it called in Python? Is it a class method? It was either a class method or a property, something like that. Or a static method, but they're not a singleton. But it sounds like it's a similar concept of only one user, and the code itself is analogous to whatever is using it. So a singleton is a script that exists only once and is globally accessible. So it creates the thing once and it always uses that, which means it's fully, it doesn't change. Well, isn't that just the concept? The same concept as a static method in Python, in the absence of a true singleton. A singleton is not the same as a static method, even though they feel similar. But they are similar, because you're saying so. A static method means no inheritance is needed, but it also means that it doesn't change. Internally, it always stays the same. Because if you don't inherit, if you don't instance it, then it's always the same thing, which means it has to not be changed. So I'm counting that it is the same, even if I'm being told it's not the same. Or similar, at the least. We're going to use the input singleton here, as we need to know if the player wants to turn or move every frame. Well, I think so. We're going to make a direction variable. So we're just seeing if we're moving left or if we're moving right, and we're doing 1 or 0 based on that. 1 or -1 based on that, otherwise it's 0. So turn and var turn int equals 0, and then if input is action pressed, UI left turn equals -1. So if we're going left, it becomes -1, and if we're going right, then we go 1. So if we're not pressing left or right, it's 0. Otherwise it becomes a number, and the negative means it flips to the other way, to what it would be if it was, you know, positive. And now the rotation. Here, instead we base it on, I guess, the outcome of turn. Turn. The thing is, what is... Oh, it's too slow. It's turn times 5. Now we can turn. Cool. And now we want to know if we're moving or not. And I'm not going to look at the documentation. I'm going to try and do it myself. Speed. And... oh, that's nice. I have Control D for speed. That's cool. Except we don't want rotation. UI forwards. So left, right, up, yes, and down. And then we have this, and we want to. Oh, we already have speed. It probably times by what was speed? Speed was 400. Let's do it by 50, and we'll see what we get with. And that might even be it. Well, it's backwards for one thing, because you know how these tools are. They love to reverse what up and down. They love down to be. Oh, it is correct. -1 for down. Okay, okay. Ah, wait, it broke left and right. My left and right broke. Left and right. Oh, I deleted the turn thing. Let's see if I can remember what it was. Now, did I have to make... no, it was rotate. Or was it rotation? Yes, it was rotate. So rotation plus equals turn times delta times like 4. Oh, I did it by myself. Look at a three point, a reverse 3-point turn. If only I drove this well in real life. If only everyone drove this well in real life. What am I saying? But I did it, and I didn't have to obsessively look at the document, the tutorial. It's going to say exactly what I did. Wait, what? It's doing it quite differently. Well, let's see what it said first. So, direction is a local variable. Yes, yes. 0 means it isn't moving or pressing a button. 1 means right. -1 left. To produce these values, we make a conditional statement. That's the if left, if right of input, which is the input. Okay. Okay. So the if, the condition is the condition is specifically the expression between the keyboard and the oh, it's explaining what a yeah. Check if a key was pressed. We'll call is action pressed. The method takes a string and returns. So it checks if it's true or not. Left and right are predefined. I gathered that. You can see and edit input actions in your project. So project settings, and checking the input map. Input devices? No. No, not import. No. Input. Oh, hee. And here's where you add new stuff. But we don't need them right now because we already have some predefined ones. Such. Why does it not take? So the hotkey I set up of F12 doesn't open. It opens the info of this. It doesn't open the. Well, that's annoying. That's annoying. I don't want you. But can we get it to give a hotkey for? No, we can't. We can't get it to have a hotkey for that. What if it's called help? I don't think it has it. That's sad. My day is ruined, and I don't want to. I want to go back to Unreal Engine 5, where everything was just perfect and performative and easy to use and optimize. I want to go back to that. You know, with all the settings and their built-in code editor in basically Python. I want to go back to. So left and right is already in the game. Finally, we use direction. What? We never use direction. Why did we use direction? Oh, that's good. I should stop showing off and changing the names of variables. So then we use the direction as a multiplier. Comment out. Well, that's just a term, but I'm better than that, so I kept it in. So this ignores the code. Yes. And then you press left and right, and you can move. To move only when you're pressing a key, we need to modify the code that calculates the velocity. So we get. So why did they do it like this? Right, so velocity is a vector 2. Oh, I see. So they're making an empty vector. And then if we're going up, they assign a value to the empty vector of up. Meanwhile, what I've done is I've just got if you want to go up or not, and then I make the up vector regardless of whether it's used or not. I wonder if there's any practical difference. They also don't have going down. I think mine is fine. I don't see why I would. Well, it's not going to be a performance difference because it might be a small performance difference because we get the vector up whether we need it or not. And yet if that was a problem, they could have done the same. Wait, they didn't have to make a vector for this one. I think they're just showing us that you can initiate an empty vector with vector 0. So, the completed script. But mine is even better than this one because I can go forwards and backwards. So in summary, every script in Godot represents a class and extends one of the engine's built-in classes. The node types in your class inherits, gives you properties. You inherit functions, which we didn't use. There's class properties and local properties, and member variables and local variables. You can define functions, which for the most part will be your class's methods. It provides several virtual functions you can define to connect your class with the engine, such as process and unhandled inputs. The inputs singleton allows you to react to the player's input anywhere in your code, especially in the process loop. And next we're going to be using signals, which I'm quite interested in, because I've heard that they exist, which makes them interesting because they think they exist. But I don't know anything about them. So now we'll find out what they are. So we'll look at signals. Messages that nodes emit when something happens to them, like a button being pressed. Other nodes can connect to that signal and call a function when the event occurs. Signals are a delegation mechanism built into Godot that allows one game object to react to a change in another without a direct reference. Using signals limits coupling and keeps your code flexible. It reminds me of the I/O system in the source engine. In the source engine, you don't have to program one button to react to another button. Like if you have a button and a door, you can call the door metal door, and then you say to the button, trigger metal door, and it now connects to the metal door without you having to specifically code what element the door is triggered by. I don't think Unreal has this property. Well, it definitely does. It has every property, but does it have it in a nicely accessible way? I don't think so. At least not as nice as this. This feels a bit like it was built on the idea of signals from conception. So you might have a life bar that represents the player's health. When the player takes damage, you want the bar to change. So you'd use a signal. Meanwhile, in Unreal, what you'd usually do is you'd have the health bar in a UI element that belongs to the player's entity and which updates every frame to get the player's health, or at least is triggered by a change in the player's health to trigger a change in the UI. But here it seems like you can have that all separate, which sounds nicer. Like methods, callable, what? A built-in type representing a method or standalone function. A variant. The most important data type. Oh, a variable. Yeah. So a variable. I agree with this. Well, isn't every data type a variant because it stores a variety of other types? It's you know. Uh-oh, I can't make. What? Oh, yeah. Uh-oh, the little cannon was here. So a callable is a variant that represents a function. It can either be a method with an object or a custom callable used for a different purpose. It can be stored in variables and passed to other functions. So it's a function inside a variable, I think. Let's see, callable. Yeah, so you make this function, and then you make the function a callable, and then you can call the callable in a bit of a different way. I don't see the point, but I'm sure it's useful. So like methods, signals are first-class types since Godot 4 are. This means you can pass them around as method arguments directly without having to pass them as strings, which allows for better order completion indefinitely, and is less error-prone definitely. See the signal class reference? I'll see it when I feel like it. Get off my back. As mentioned in the introduction, signals are Godot's version of the observer pattern. We'll now use a signal to make our icon move and stop by pressing a button. We'll be following Godot naming conventions, Pascal case, all caps constants. Yeah, this is mostly what I do, I think, when I remember. When I remember my own naming convention, this is what I do. So classes in Pascal. Well, what I tend to do is I put my classes like this. No, my classes like this, and my functions like this, and my variables like, no, I don't do that. I use like this. But caps like this, no, cons, like this, yeah, like that. That was very tricky. Anyway, so to add a button to our game, we'll create a new scene which will include a button. And the sprite that we created earlier. And the sprite 2D that we created. Oh, so we're going to be using this whole thing as a node, as a scene node. So first we go to scene, signals. Oh. To create a new scene by going to scene, new scene. Add child node, but we want a new scene. How do we make a new scene? There is no new scene button. Scene. So scene, new scene. And that's a bit of an oversight. And we're going to make a 2D scene. And we're going to put add a child node, and we're probably going to put our what did we call it? Label. No, what did we call this thing? Did we call it label? That's a baddie. That's a stupid name to call it. What is this scene called? The root node of a scene is recommended not to be transformed. Oh, that's fine. Don't be such a Debbie Downer. First script, that's not what the scene is called. What's this scene called? If it's called label, or sprite 2D, which is just as bad of a name, because there's already a thing called sprite 2D. So add child node, button. Well, first we'll just add the button. I'm sure we'll get to how it works. So we have a button, and the node is very small by default, so we'll resize it. That is very small. We'll put it here. No, we'll put it in the middle. That's not the middle. What are you doing? Middle. Middle. Middle? What? I want I want it to go to the middle. What? I want this. Middle. Well, what do you do? Horizontal line, but you don't do anything. But you don't do anything. No. Stupid. What? What? Oh, do I remove that? Okay. Okay. No, I want to clear this because it's there. Okay, so click and drag the bottom right. Does it have to be the bottom right handle? Can't it be any handle? If you don't see the handle, select mode. Click and drag on the button itself to move it closer to the sprite. What sprite? We don't have a sprite. We removed that scene. What are you talking about? You said add a new scene, right? New scene. Add a node 2D. In the file system doc. Ah. So the file system, we drag, I guess this. Yeah. Into the scene. And is it going to move when I press to move? It is. Signal button. Signal button. And now we have the scene with the button. Okay. So now we have the save a newly created scene. If you haven't, we've saved it and run it. The button will be visible, but nothing will happen. Connect a signal in the editor. Here we want to connect a button's pressed signal to our sprite 2D. And we want to call a new function that will toggle its motion on and off. We need to have a script attached to the sprite 2D node, which we do from the previous lesson, yes. You can connect signals in the signals doc. Select the button node and click the signals tab. It displays a list of things that are pre-created for this element type. Cool. Double-click the pressed signal to open up the connection window. And I guess now you select this one. On button pressed, there you can connect the signal to the sprite 2D node. The node needs a receiver method, a function that Godot will call when the button emits the signal. The editor generates one for you. By convention, we have these callback methods. We name these callback methods, yes. So on button press, when connecting signals, why am I having such a hard time reading? When connecting signals via the editor's signal doc, you can use two models. The simple one only allows you to connect nodes that have a script. I'm going to take my shirt off. Maybe I'm getting too hot. also taking off my trousers because it's 26 degrees. Why am I wearing my headphones? There's no audio. I've been sitting here with my headphones on. There, I can see better now. When connecting signals via the Editor signal dock, you can use two methods. The simple one allows you to connect to nodes that have a script attached to them and creates a new callback function. So this appears because we already have made a script. If it didn't have a script for it already, it wouldn't be here. It sounds like it. The advanced view lets you connect to any node and any built-in function. Any built-in function. So that means you have access to add arguments to the callback instead of options. You can toggle the mode. Yes, I saw that. But what does it mean? Add extra arguments. So vector2, string, color, float, int, argument 1. What, I can't rename this? Why can't I rename? Does it really not let me rename this argument? Well, I guess you don't usually name... Yes, you do. Of course you name arguments. What about an integer? Argument 1, argument 2. But why can't I name these? Well, I'm sure it's something you can do. So, but for now... So for now, we're just going to use this one, I think, and click connect on button pressed. Connect. And now we should have, now we have a little extra function down the bottom here, replaced with function body. So if you click the connect button, if you click the icon, if you click the icon, a window pops up and displays information about the connection. This feature is only available when connecting nodes in the editor. So from the button, the signal is pressed. What do you mean? What do you mean pressed? Oh, it's pressed. Pressed. Preston. Who's Preston? I know him from somewhere. Target sprite 2D, this thing. Okay. Cool, I like this. Now, let's replace the pass keyword with code that will toggle the motion, which I'm going to try to do myself. Var can move, and that's a bool, and it equals true. And now, if not can move, return. True not declare. Oh, was it lowercase? Yeah. And then this will stop. And then when we do this, can move equals not can move. Get that? So if not is like negative, so not true becomes untrue, not untrue becomes true. So this will and equal itself, so it makes itself not itself. How do I run it? So I can move, and if I click the button, I can't move. And I can move, and I can't move. See that? Oh, I can also use enter to... I can also press the button with enter. Alright, well... Oh, I covered it up. There it is. I mean, this thing is cool, but it also means I risk forgetting it on and leaving it in the way. So, moves thanks to the coding processed. A method to toggle processing on and off. I guess that's another way. Well, I guess it's technically well, it depends on what you want to do. Like, if you want to disable everything, I guess it's better to just turn off processing because it's still going to run it. And since we run it to do nothing with it, it's wasting its time running this part. But if we just turn off the processing, set processing is not in processing, well, we can just make use of this. Set button to can move, and now we remove can move from there, and we still make use of this version, except now it doesn't even try to process because processing has been fully disabled. Good. Where did my thing go? Oh, it's because there. So now we're set process. I should be noting these built-in arguments, but I can do that later. The function will target the processing, and therefore the icon's ability to even move because it's not being processed. We need to simplify our process function to move the node automatically. Well, we don't have to, but it worked without doing that. So your complete script should look like this. Well, this just makes it automatically move. It's a bit... Now, this does work, of course, but it doesn't let you turn it back on. So running the scene and blah, blah, blah. Wait. Oh, I see. So there's no need to track an external variable. We can just use the same concept of is not and set process to not is processing. And now we don't need that extra variable. Alright. Because we just make it, if it's not, we make it not processing if it's processing, and make it process if it's not processing. Because not. So connecting a signal via code. So you can connect signals via code instead of the editor. This is necessary when you create nodes or instantiate scenes inside of a script. Godot has a timer node that is useful to implement skill cooldown timers, weapon reloading, and more. Back to the 2D workspace. In the scene dock, right-click the sprite 2D node and add a new child node. Add a child node, and I guess we want to get a timer. Search for a timer and add the nodes. When the timer node is selected, go to the inspector and enable the auto start. Click the script icon. Click the scripts icon and it takes you back to here. We need to do two operations to connect the nodes via code. We need to get a reference to the timer from sprite 2D and call the connect method on the timer's timeout signal. To connect the signal via code, you have to call the connect method. To connect to a signal via code, you need to call the connect method of the signal you want to To connect to a signal via code, you need to call the connect method of the signal you want to listen to. In this case, you want to listen to the timer's timeout signal, so but it's saying here that we call the connect on the timer's timeout. But here it's saying we need to call connect of the signal. So are we calling connect to the timer on the timer, or are we calling it from the signal to the sprite? It's sort of, maybe I'm misreading it, but it seems like it's not saying which one. We want to connect the signal when the scene is instantiated. And we can do that using the node ready, which is called out automatically when the node is... Couldn't you just call it init? I guess you're using init for other places. Or maybe it's a bit of a strange name for someone who doesn't know what init means. Or at least isn't used to init. Init. To get a reference to a node relative to the current one, we use getNode. We can store the reference in a variable. So, function ready, func ready, and timer equals getNode timer. I guess because it's the same. Is it going by name? Oh. Is it going by name? I guess it is. Oh, it can either be label or timer. It doesn't mention the label down here. Wait. So this thing is this, is it not? Like this thing comes from here. And this has a label. Well, the easiest way is to just say text box. And now if it changes its name over here to text box, yeah, so it's basing it on the name, and it's finding not only the elements here, but the ones actually in the source of that scene, alright? So we get a node based on its name. when it's ready, which is when it's fully loaded. And then connect on timer timeout. Timer timeout. So, which would therefore suggest that Signals has, well, it has one called timeout, but not on timer timeout, or on button pressed. So the button has one called pressed, but that defaulted to a name of on button pressed. So can you call this anything, or it has to be specific? If I go to connect, this gives me on timer timeout, but I guess I can call it anything. And the point is to name it here, to reference it here. So let's see if we define on timer timeout in the timer element, or if it does rely on a specific name. Timer. Oh, time. Okay, timeout. So we just go. So that's how we set it up. We just go timer, timeout, and here is where we get the reference to this element, the timeout signal, and then we connect it. So it's connecting to. So we get the timeout signal of the timer, and we connect it to something. And it can be whatever we want, and then we have function something, like that. But in this case, we're going to call it on timer timeout. See that? Cool. All right. So that's how it fits together. So far, not a bad software, I'd say. Go away. Why is this? Oh, it's because it's a. Oh, that's cool. So if you're using a virtual function that you're inheriting from something, it'll give you this little button to go see where it's coming from. That's nice. And this is a. Oh, these are cool. I like these little elements. I like them. So the line reads like so. Yes, I know. We get the timer's timeout signal and we connect it to a function of our choosing. When the timer emits timeout, we would call the given function. And it's added to the bottom. I added it already. By convention, we name these callback methods. You said that. So on note name, signal name. Here will be on timer timeout, and on timer. So visible equals not visible. Fine. So we're going to make it disappear. So it becomes invisible. Visible equals not visible. And now after 1 second, it's going to like disappear. Oh. Maybe I got something wrong. Oh, invalid access to property or key. Oh, pop. Wait, it comes back and disappears. Huh? 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 Oh. 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 Da 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 da. Do 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 do. Property. Toggles the value. It blinks on and off. And that's it for our little moving and blinking icon. And the stuff. How do I compare with theirs? Well, can I move you to the right a bit, or not really? Huh, I can't. But I can do this. So let's see. I have my speed value and rotation. Process, which is getting it from moving left and right, which has been removed from this one because they didn't want us to have keyboard input, which is probably the better idea because you just want to test it. But I want it to be more fun. On button press, disable processing, and on timeouts, timeout. Yeah, it's the same, but even better because it's called ang speed instead of angular speed, which is shorter. I could have got ang speed. There we go. And so you can define custom signals in a script. If you want to show a game over screen when the player's health reaches 0, you can define a signal named died or health depleted if you're a psychopath when the health reaches 0. So you just write signal at the top. You're dead. And now that's a signal. Let's see. Does this now have a? Oh, you're dead. You're dead. And now we can use this thing in other places. Let's see if I can figure something out. What can display this? Maybe text. But I want like a bar, like a health bar. Progress bar. And I want it to be slightly bigger than non-exist. What? No, what? What happened? Oh, nothing happened. It's still here. So let's see. So can I put your dead and connect it to the progress bar? Target method not found. But if I put it into advanced, then it will let me. Target method not found. Specify type. Well, I don't have to specify a target method. I'm using advanced mode, and it said it will make one for me. But I can add a script. New script. New script. Show you dead. Empty. And now I should be able to connect your dead to the progress bar. And when you're dead, how do you change the... I wonder how you change the progress, the fullness of the progress. The control used for visual representative of a percentage, color, outline size, fonts. I want fullness. Fill. No, that's the style of the progress. Fill modes. Begins from the beginning to the end. Property descriptions. The fill direction. show percentage. I don't really want the percentage in the first place. So it should be, oh, I can just look at these maybe? Value. And we don't want the percentage, but we can change the value. So is it just called value? Is it going to tell me? Value. So if what was it? Func ready? Ready. Can I set the value to 1? I guess that's 1%. Now what if I set it to 10? 10%. So when you die, set it to value 100. And now I gotta close this, it's really distracting me. So now we just need a signal for your debt, which you would trigger from here. Signal your debt. Now let's see how you actually connect. So you create the signal. Signals represent events that just occurred. We generally use an action verb in the past tense. I see. So a signal is an event that just occurred. Past tense verb. Your signals work and they appear in the signals tab. So call emit on the signal. Let's just put it on the button, and that's probably going to be you dead emit. Oh, you dead. See, I figured it out. And this is just a very typical health thing. You lose health, and then when health is 0, you admit that you have no health. It can help you declare arguments, which is pretty nice. I remember trying to do that in Unreal, and it really didn't seem to like it. Just doing something as basic as adding some arguments and sending that information from one place to another. It didn't like it. Specify the argument names between parentheses. Yes. The signal arguments show up in the editor's signal doc. Godot can use them to generate callback functions. Have you can still emit any number of arguments? Oh, you can emit any number of arguments. So it's just like calling a function in Python. You can put, well, no, it's not actually, because Python expects a certain number of. So if I didn't declare something and I put like 25, and now this expects a value of an integer, and I then use that value, it doesn't work because it's because it doesn't want. Oh, it's because int. So does it now allow me to just send this random value? No, it doesn't. But it said that. Oh, it's because I didn't put it in here. Value. No. So you have signal health change, and then you have the value. And we have the value, old value, new value. And then when you run the script, you put it in the thing. Isn't that what I've done? So why isn't this value? Oh, is it because I've called it value and it's overriding its own name? Probably that. New value. And where is... Oh, it doesn't need it. Now this maybe will... Huh? Alright, that's cool. Well, what if we now have plus equals the value, and now every time we press it, it's going to go up by 25%. See that? Okay. That's pretty nice. But does it have to be defined? It does not have to be defined, so how is it? I guess it's by what? It must be by index order. If we have not, must be by index order. Huh? Is it not by index order, or is it by like reverse index order, or is it that it just that it treats this whole thing as a tuple? So it would be like, instead of seeing 0 and 25 as two separate things, it just sees 0, 25 as one thing. I mean, that's how it works in Python, which would mean that if you have some kind of garbage value, you have to have the same number of inputs as you had outputs, which should now mean that 25 was the garbage, so it did nothing because it's not connected to anything. Now we put it in the first place, and it works because that correlates to the new value, which goes, okay. So you don't have to specify them here, but it does have to have the same number of elements coming in as going out, unless... Oh. Unless, what if we have info and we get the 0th data point? And if this works, it doesn't. So what is this receiving? When I write here, it just says args array. But I can't get something from it. Oh, wait a minute, I can just use print info. Received info. And now... The variable speed is shadowing an already declared variable. Oh, it gets defined here and here. I don't care. As in, yeah, it's a good thing that it's showing as an error, but I don't care. So on button pressed, error calling from udet, callable. Progress bar expected 1 argument, but called with 2. Okay, so it doesn't exactly. Well, of course, we can just actually make it a tuple, and now it's just going to be like, okay. What? What are you talking about? The error expected a closing parenthesis after, but it's got one, right? Expected a closing bracket, which it has. Maybe it doesn't have tuples. Does GD script have tuples? Oh, it doesn't have tuples. So, oh, can this get out of the way? So in Python, you can have a list, and you can have a tuple, and they look basically the same, and they act basically the same. The difference is denoted by the bracket, but a list can be modified later. So you can have like lists, my list, my tup, and my lists can then have appends you can change it. You can change this later, but my tuple you cannot change. So this would give an error. And the point really is just control. I don't think it's a performance thing. I really think it's just about controlling access. Because if you have something like a constant, you just put it in a tuple, and now it can't be changed later. And anyway, so it doesn't seem that it has tuples. It only has lists. I'm able to write. I'm able to write to file. File is in use. What do you mean it's in use? I know it. I know it's in use. I'm using it now. Save it. Unable to write to file. Signal button. File in use. Locked or lacking permissions. Oh, it was still running even though I'd closed the hotkey. So now, see that? Because we put the two things into a tuple, and then we just got the first one. Of course, this is a bit meaningless because it's because it's really just like the obvious of how that is meant to work. Let's see. I just have to get the link. I gotta copy the link to a little owl, and let's see if it's the right one. Seems to be. No, I don't want to close YouTube. I need it open to see all my hundreds of viewers and what they're saying. So this isn't really anything that incredible. It's just how programming tends to work. But still, we found out that there's no tuples, and we figured out how to give any arbitrary amount of information. Because now we can just give like blah, 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 blah. It's probably not going to work. But anyway, so any node in Godot emits signals when some. What do you mean any node in Godot emits signals? You mean they all do? Or they all can? Or does it mean that anyone can cook? Does it mean everyone is capable of cooking, or that a good cook can come from any? Which is it? Hi, Beth. So other nodes can connect to individual signals and react to selected events. Signals have many uses. reacting to states, collisions, or an element of the interface changing. For example, in area 2D, representing a coin. What? An area 2D representing a coin emits a body signal whenever the player's physics body enters its collision shape, so that you can pick it up. So it just has an area, a collision box, and with the collision box, when it hits the player's body, it just triggers, goes blah blah blah. You picked it up. Oh, we're at this point now. We've hit the landmark of finishing the. So we're in getting start. So for the context of Bessie, this is Godot. It is a game engine, and I started using it a couple of days. I recorded my first experience with it, but I didn't stream it. But this one I decided to stream it because I just felt like it. I don't know why. And I read the about, and we're doing the getting started. The setup of using nodes and scenes. I'll put part 1 on YouTube at some point, and you can watch that if you find it interesting. And it goes through all of this part. And we just figured out using signals, which lets you send information around. Of course, I've broken it a bit because I've been screwing around. And I don't want the timer running right now. But I made this thing, and you can turn it around, and you can fly it about. It can go backwards. And there's a button which will stop it. And now it doesn't move. And now you click it and it can move. And now it doesn't move. And that's been it, really. And in the last minute, we figured out that we can send a signal, which is the whole point of what's being seen. Signal emits with some value, and the UDET has been set up with the signal system to target the to this progress bar. This is a progress bar. And when it emits this, it triggers this because it's been set up. So from sprite 2D, you get the progress bar, and it adds some value, which you can see here. See? You have to watch the whole stream if you want to get what's going on. But the point is that we've just finished this part, and now we're on to this part, which is a different section to the step-by-step. It's your first 2D game. And it's a bit of a... Get out of the way. It's a landmark. We hit a landmark. So in this step-by-step tutorial series, you'll create your first complete 2D game with Godot. By the end of the series, how big is the series? Oh, that's small. Oh. That's not that small. And after that, of course, we have your first 3D game. By the end of this tutorial series, you'll create your first complete 2D game with Godot. By the end of the series, you'll have a simple yet complete game of your own. You'll learn how Godot works, how to structure a project, build a 2D game. It seems you have some programming experience already. It's called Dodge the Creeps, Dodge the Creepies. Your character moves and avoid the enemies. Create a 2D game, structure the projects, move the character, spawn enemies, count the score. We'll find another series where you'll create a similar game in 3D, but start with this one because 2D is exponentially simpler than 3D. Going from the 2 to the 3 is much more of a difference than a 50% increase. It's more like a 3 times increase, maybe 5 times, who knows. Well, maybe it's a logarithmic increase and then it's 10 times the difficulty. Maybe. Maybe. Maybe 3D is logarithmically more difficult than 2D. That's possible. You can find the completed version. Why am I typing to you? You can hear me. You're dead. You are dead. Oh! So the step-by-step tutorial is intended for beginners who followed the step-by-step. Oh, we just finished that. You and me, Bess, we just finished it together. I thank you for your contributions. I don't think I would have figured out half as much as I did without your contemplation. If you're an experienced programmer, well, I don't know. No. I've never had a job. We prepared some game assets you'll need. Download them. I'll download them later. I downloaded them. See, I said later, but I didn't say much later. Extract to there. Right. I got them. So setting up the project. I guess we're going to be making a new project. So we'll create a new project. There was a hotkey for this. What was the hotkey? Control Q? Oh. Okay, Control Q quits the software. Okay. It quits the software. There you go. So the project project manager. Let's get the ID thing. You like it? You also see there's a little there's a little monster over here. Little monster. So wants me to go to project settings, and window, viewport, Spidey thing. What Spidey thing? What? Spidery. Slidey. The slidey slide. Yeah, it's quite slick. Yeah. Window. Where is window? Ah, window. And it wants me to reframe it. So what? I'll meet you halfway. You want vertical and I want a horizontal. I'll meet you halfway with square. Square game. Oh, there's no scene. Square game. And it says stretch mode to canvas items. What does this do? The base screen size is stretched to cover the whole screen. Whatever, I'll figure that out when I can. And aspect is kept keep. In this project, we'll make 3 independent scenes: player, mob, and HUD, which we will combine into the game's main scene. So that's 4 scenes. Silly. Not 3. In a larger project, it might be useful to create folders to hold the various scenes and their scripts. But this is relatively simple, so we'll just dump them all in the root path. We can now move on to the next lesson. With the project settings in place, we'll start making the player-controlled character. The first scene will define the player object. One of the benefits of creating a separate player scene is that we can test it separately. even before we've created other parts of the game. What if it's a 3D character and it needs an environment to move around in? Well, I guess then maybe you'd make a test environment. What's it called? A gray box? I guess you'd make a gray box for doing that. So I guess we're going to need to make let's make a new folder anyway, because I want one. Content, code, assets. It's not exactly an asset, it's the code, but it contains the core scenes. I'll just put candle. And we're going to need a new scene. Player. Oh. You couldn't see. I made the candle. I wonder if I can get this to appear and disappear dynamically if the web page is selected or not. That would be useful, because I keep forgetting to turn it off or to turn it on and it's in the way. And there's a little mouse on my screen. We need to choose. To begin with, we need to choose, as a general rule, a scene's root node should reflect the object's desired functionality. So on the top left, we'll make a new, and it'll be a character body. No. We'll make an area 2D, but Godot also provides the character body 2D node, specifically for 2D characters, which includes built-in support for some of the processes explained in this tutorial. Usually character body 2D would be better choice, but since we want to teach you how to do that, you'll be making it yourself. So instead we'll be adding an area 2D. Okay, area 2D. When you add the area 2D, Godot will display the following warning next to the scene tree. That this node has no shape, so it can't collide or interact. Well, you're right, it has no shape. The warning tells us that it requires a shape to detect collisions. We can ignore it for now because we're just setting it up. Once the visuals are ready, we'll add the shape. This will allow us to accurately size and position the shape based on the sprite. Of course. We can detect objects that overlapped or run into the player. Change the node's name to player. By double-clicking, I don't need to rename it. What do I do with it? Before we add any children to the player, we want to make sure we don't accidentally move or resize the player. So we'll click the icon to the right of the lock. Don't we want to click the lock itself? Preventing selection and movement. And this one, group. What do you mean group? Why do we want to group it? Since we don't want to move or resize them by clicking on them, select the node and click the icon to the right of the lock. Group the selected node with its children. This causes the parent to be selected when any child node is... Okay, I'll just click it. And I'll rename it to player. It's already called player. Player. It's already called player. I guess it's because... Why did we make player? Player area. But now I don't know if they're referencing the... But now when they say player, I don't know if they're referencing that player or the other player. Can I see an image? Player. Oh, they've made it the root node. So they've gone like this. No. No, go away. What? No! Make roots. Make roots. Make scene roots. And then get rid of this one. Because it was... name this. No. Play. I shouldn't have renamed. I shouldn't have rebound F2 from rename. And now save. What? As player. Okay. What do you mean confused? I'm not confused. I'm baffled. That's a fully different emotional context to experience. I'm also very zoomed in. Where's the window? There's the window. So save the scene as player. That's done. So click on the player node and add an animated sprite 2D node. This will handle the appearance and animation of the player. There's a warning, as always. An animated sprite requires a sprite frame, which is the animations it can display. Make sure you have it selected and then click Find Sprites. So, what was it? Add animated sprite. Animated sprites. And then you find the sprite frames. It says no files found of this type. So, empty. New sprite frames. Click on the sprite frames you just created to open the sprite. The frames panel. On the left is the list of animations. Click the default one and rename it to walk. Walk. Walk, walk, walk. Then click the add animation. The add animation button and name it up. Up. Find the player images in the file system under art. These aren't the player, those are the monster. And you have walk. I guess you add these to walk. And these two up. Sprite. Walk. And up. Walk, up. Why isn't it? Those for the walk, and those for the up. The player images are a bit too large for the game window. Well, not if you zoom out. Oh, actually they are. This is the size of the window. Can I run this now, or it's not going to let me? What? No, I just want to... It's a bit big, I guess. If you say so. Stop me. So the player images are a bit too large for the game window, so we need to scale them down. Click the animated sprite. And the scale 2.5. Scale 0.45, because, it's better than 0.5. It's more refined and specific. And now it's a bit smaller. Slightly smaller. You can find it in the The inspector. Oh yeah, the inspector. Finally add a collision shape as a child of player. So add collision shape 2D. I guess a sphere. This will determine the player's hitbox, the bounds of the collision area. For this character, a capture shape gives the best fit. So next to shape in the inspector, click empty, capture. And I gotta resize it to the thing. Wait, I want collision shape and then the and he's a little faster, but he moves very slightly every frame. That's not fair. It's going to be an unfair hitbox. Look at the little mouse. And so this is now the collision area, this capsule. When you finished your player, the thing should look like this, which it does. Look, it doesn't have an error. Pop, pop. Once this is done, the warning on the area has disappeared. It now has a shape and can interact with other objects. And now I'll add a script to the player node to move and animate it. And then we'll set up collision detection to know what when the player got hit by something. So we put the export keyword, and that allows it to appear over here. Click on the player node, and you'll now see the property in the thing. Remember, if you change the value here, it will overwrite the default value in the script. Yes. If you're using C#, which I'm not, so shut up. So your player script should already contain a ready and a processed. Ready, process. The ready is called when node is prepared, when it enters the scene tree, which is a good time to find. So this is like when it first appears, and you can find the screen size with get viewport rect. What? So this variable get screen size equals get viewport rect size. Wonder why we need that. And now the process will define what the player can do. Process is called every frame, and we use it to update the elements that will change often. For the player, we need to check for the input, move it if the input is telling it to move, and set the animation. First, we check for inputs if the player is pressing a key. So we have 4 direction inputs, up, down, left, and right. And they're in the project settings under input map, which doesn't appear on this window. What if I can make a new window and have it as the project settings? Right. So the projects. So in the input map, you're going to add move right. So in the input map, you can define custom events and assign different keys or other inputs. Or use the arrow keys. You can use the arrow keys. I'm going to use the keys I want to use, actually. So projects, project settings, and input map. Click on the input map tab, type move right, add new action, move right, add. Move, and I'll copy that because it's going to remove it. Move left, move forward, move back. So these are the inputs that are going to be available for the game. And now that we have these, we need to assign the key. Don't forget to use the arrow keys. I'm not going to use the arrow keys. I'm going to use the keys I want to use, which is WASD. Move right is going to be D. Left is A. Forward is W. Backwards is S. I think. Yes. And the listening for input should be selected. Yeah, it figured it out. What's this? Oh, it's because it's also looking for the arrow key. I mean, I could bind it to work on both the arrow keys and WASD. So now you can use WASD or the arrow keys. But why would I do that? I'm not a scrub, you're a scrub. You use the arrow keys in your early 2000s computer games. Select the OK button. The right key when I assigned all the keys. Also, what OK button? It says cancel. It says close. Look, it's wrong. It says it's going to say OK and cancel, but it just says, oh, unless it's a, oh, it's talking about, it's talking about a different window. Okay. The input map now looks like this. So let close. And we have the inputs. Why don't I join you in a bowl of soup? I'm not sure it both fits. I'm not sure how you're fitting, actually. You can detect whether a key is pressed using input is action pressed, which returns true or false. And it's got the move directions. And I'm going to put this, because I want to be a bit more tidy, I'm going to make my own little function called func get inputs. Or maybe I shouldn't do that because I need to actually get the information out of them. Well, I can get move velocity, and it will return a vector 2. No, vector 2. And now this is going to check the move forward, left, right stuff. So first we need an empty vector, which we can see is velocity vector 2. So the empty vector is variable velocity, which is a vector 2, which equals vector 2, 0. Now a vector is just like two values together, like this. This is a vector 2, and then this is like a vector 3. That's really all it is. But a vector 0, no, a vector 2, 0 is a vector 2 that just has zeros in it, which means it's empty and it doesn't have information. And we will return, when this function is done, we will return the velocity. Why doesn't it like this? Could not find vector. Well, it's because I spelled it wrong. That's your problem. You should figure that out. So this process gets called every frame, and we will get move velocity, get the movement velocity. So every frame, it's like this. This process happens every frame as it runs, and every frame, the first thing it does is get the movement velocity, which then runs everything here between function get movement velocity and return velocity. So now we're going to map the inputs to adjust the velocity. So if the inputs is action pressed move, well, we're going to want 4 of these with a colon to, no, 3, and now move forwards, move back, move left, move right. And these have the same name as we set in the project settings: move left, move right, move forward, move back. So now when we press W, A, S, or D, when we press one of these keys, it has been input mapped to trigger move right, move left, move forward, move back, which therefore means is action pressed move forward will be true. Otherwise it'll be false. So if we are moving forwards, we need to set the velocity x plus equals 1, because the x is, wait, y, because x is along the right, y is going up, just like in a graph, the x and y on a graph. And the vector 2, as I said, is just two things in a list like this, and this is pretty much like a coordinate on a graph. Like you have 0, 0, which would be the bottom left of a graph, and then you have like 1, 0, which is like the x and the y of the graph. You get it? So we're just setting the coordinates, the 2D coordinates in x and y. So when we're moving forwards, we want to increase our y position, because that's going to go up. And if we're moving backwards, we want to reduce it. Same thing if we're moving left, we want to decrease, because it's the negative, x minus 1. And when we move right, we want to increase our x position. The x and y position on a graph. Isn't that right, Beth? Stop talking about your soup. You didn't stop bathing in your soup. I'm not going to fit in there. What do you expect from me? And then we return the velocity. Because if we're moving forward, backward, left, or right, and we let that influence the velocity, and then we give that velocity back. So this value is the vector 2, which the get move velocity is returning. So it's like, get it, get the velocity, get it, and it goes, because this line runs this function and everything in it, and it figures out the movements that you want to do, and then it returns. See, return, and this arrow means like return, and it's going to return a vector 2, and it returns velocity, which is a vector 2. So it returns this to here. So I can close this, and I don't have to look at it now, because it's figured out. I can even write this a comment, I think. Does comments work? If I hover over this, I don't get a comment. Maybe it wants a docstring style comment. Does it want a docstring? Oh. Does it want the comments above it? What? Can you not assign a comment to the thing? No description available. Well, that's not nice. I'll have to figure that out at some point. So I'll just close this, because now we know what it does. And now we get the value from this, the vector 2 that this returns, which is going to be vector velocity, which is a vector 2, and it equals to the value of expected and end of statement after expression. Well, that's because you put a colon there. No, it needs a colon. Var. Var. So var for variable. It's a variable. Velocity, which is what we're calling the variable. We can call this whatever we want. Vector 2, which, as we saw, is the 2D coordinates, and it equals the return of the function, which is this velocity that we calculate across this. And now that we have this velocity value, what do we do with it? If velocity length is 0, that means we're not, wait, if it's greater than 0, it means we're moving. Otherwise, we're not moving. So, if the velocity, length, and length is, it's just where you add them together. So if you have the coordinate like this, length would just be 1 plus 3. Yeah, and that's all that length does. So if the length is greater than 0, because if the only way that it's not greater than 0 is if both points with 0, which means there's no movement, right? So if the velocity is greater than 0, it means we are moving. Otherwise, we are not moving. I'm going to put this, why do I put this comment to look nicer? Maybe here? Or maybe on the first line of, yeah, I guess that can work. It's fine. So we start by setting the velocity to 0. See? 0, 0. The player should not be moving by default. Then we add up, down, left, right. Horizontal and vertical movements. Alright. If you hold right and down at the same time, the velocity would be 1, 1. And since we're adding the horizontal and vertical movement, the player would move faster diagonally than it would horizontally. This was actually a bit of a well-known little side effect of many older games, that if you move diagonally, you run faster. Even 3D games. I think in the original Doom, I think in a lot of games back then, if you run diagonally, you move a bit faster. Hell, I think in Left 4 Dead 2, you move diagonally a bit quicker than you move forwards. Because of this thing of adding them together rather than having them normalize. We can prevent it if we normalize. See, it's just what I said, normalize. Which means we have its length become a maximum of 1, and then multiply by the desired speed. Yeah, see? Vector, I know vector, vector. You can also check whether the player is moving. What? We can also check whether the player is moving. So we can call player stop. Oh. Yeah, so this just gets the sprite. What does the $sign mean though? I guess they don't really want to bother to explain this properly right now, because they're not exactly. Oh, the $sign is the shorthand for the get. So the get node. So in the code above, animated sprite 2D is the same as get node animated sprite 2D. I see. Or returns node if the node is not found. Since animated child sprite 2D is a child, it will find it. So if it is moving, we'll get the animated sprite 2D and play it. Otherwise, if we're not moving, we'll stop it. And what this will do is it will either play or pause this animation. See that? So if we stop, it'll go up and then up. And what else did it do? Velocity. It takes the wait, velocity is already a used term. Velocity equals velocity normalized multiplied by the speed, which we defined ages ago back here. But the thing is, how is this going to... I always move faster and... Have you tried it? Maybe you do. Why don't you go to the garden right now and try sprinting in a diagonal direction? So, how does this actually move it? Is it because velocity is inherited from area 2D? Or is it because it hasn't been set up yet? So you take the velocity, you normalize it, and you multiply it by the speed. So it averages out and doesn't let you go faster in diagonal, like best you can. Now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Oh, I see, that's what the screen space is for. So I guess process clamp. I guess put it at the end here. So position. Oh, this is where we add the velocity. See? So the velocity is created and it isn't used here. I mean, it is used, but this doesn't apply it as movement. It's just the information. So the position, which I guess, see that? It's the built-in position. It already knows it exists because it's probably defined in the node 2D, which this is area 2D, which inherits from collision object 2D, which inherits from node 2D. So position plus equals the velocity that we made multiplied by delta, as we discussed earlier, which everyone was here for. It's described on page 194 of your guidebook. Oh, I have food that I have to eat because it's hot. And well, I burnt my position clamp. Position equals the position. See that? Position equals position. And then clamp. And we clamp it to vector 0. What? Why? And this. Oh! Vector 0, 0, 0, because 194. Oh, I was right. I was close though, wasn't I? But was I close? I don't remember what I said. 194. I'm in the house. He's talking with his parents for several hours. I think. I don't know if it's several hours. I'm not sure how long I've been going for. And he's brought me potato that he's fried in the air fryer. So screen. So 0 is the 0, 0 coordinate, which is the bottom left, and screen is the maximum, which is the top right edge. So between those two, you get the area, screen size. And now if I move, it moves. But it can't, and it moves. See, we did this. Up and down is reversed. No, up and down is reversed though. So to fix up and down being reversed, you can just make this. No. That and that. And now we have movements up and down. And you can see it moves when it's moving. You know, the little feet move. And then it stops. And I think I'm gonna stop streaming now because I have hot food and I'd like to eat it. Also because I've been going for 2.5 hours. And because I got a character to move. Oh, you can't see it. But why can't you see it? Ah, there. You couldn't see it before. But we have this little thing and it moves around. And its little feet move and it moves. And its feet moves. Its feet stops moving when it stops moving. And it hits the edge of the screen and it can't get out. It's trapped. And then we have it, a little character. And all it took is just this little bit of code to get it to move around. And that's I'm gonna be wrapping up because I gotta eat my food. So I see. See. I'm leaving.